Okay, here's the long-awaited video on derivatives of inverse functions. And, really, it's not going to be that different from what we talked about before. We'll have a few examples here. A couple are pretty straightforward. One's kind of interesting and one is very interesting. So, all in all, when we do inverse functions, and because this first problem is dealing with g and h, I'm going to use g and h, but we can use any version thereof. What we want to look at is that derivatives, excuse me, inverse functions undo each other. So g of h of x would equal h of g of x would equal x for h and g being inverse functions. Okay, so whatever h does, what you put in x, h does something to it, and then you take that result and you drop it into g, and g will undo it, giving us back to x. If we look at that as a map, this is the domain of g, and we have some x sitting in there, and we perform a g on it, so we do a g and we get some g of x. Well, that g of x is sitting in the domain of h, so we can do an h on it, and if we do an h on it, then we get, there's that g, then we go right back to x. So they undo each other and they can go back and forth either direction. Now, so let's do some problems. There is a formula, and I really try to remember the formula. I can't remember the formula. It's not intuitive to me. So where I go with it is I'm going to write it out every time. And, if you remember formulas or otherwise can kind of think your way through this, fantastic, do that. Just be correct. My brain doesn't work that way. What I have figured out and what I keep learning is that whatever variable prime, if you're looking for a variable prime, that has to sit on the inside of the function. So in this case, I'm going to start with g of h of x. Well, if g and h are inverses, g of h of x is x, and now I can take the derivative. If I take the derivative, g prime of h of x times h prime of x equals 1. Now, why if I'm looking for h prime of something, why does the h go in there? Because whenever I take the derivative, out comes that h prime, and that's what I want to solve for. So I'm going to go ahead and divide both sides to get h prime of x equals 1 over g prime of h of x. Now, some people can remember this formula, and you can start right here. That's fine. I don't remember it. Get over it. So, but I can remember what an inverse does. And now we just work through this. Here we go. The following table lists some values. Well, I want to find h prime of 1, so let's throw a 1 in there. H prime of 1 equals 1 over g prime of h of 1, because I'm throwing in 1. Well, h of 1 is given to us right there. H of 1 is 3. So this becomes 1 over g prime of 3. Well, what's g prime of 3? G prime of 3 is negative 2. So this is 1 over negative 2. Our answer is negative 1/2. Okay. Now, this is a really easy one because, man, they give us everything right there. We didn't have to map anything backwards or whatever. So what's going to be slightly more difficult? Slightly more difficult is something that looks like this. And let me scoot that up just a little more. Let's see what happens. We now have f and g. F is the inverse of g. We're trying to find the f prime of 0. So I'm going to do g of f of x equals x. Therefore, g prime of f of x times f prime of x equals 1. We took a derivative, and now we can solve for f prime. I'm going to write that up here. F prime of x equals 1 over g prime of f of x. Well, we want to find f prime of 0. That's what's being requested over there on the left. So f prime of 0 is going to equal 1 over g prime f of 0. Now, I'm not worrying about this g prime at all. My brain isn't working that way. I know right now I have to find f of 0. But f of 0, we look around, we search up here, well, this is g of x. And they give me that. So I don't know what f is, and I don't know what f of 0 is by a function, but I do know that g and f are inverses. So g has given me this thing that for g of x, if I put in 1, I get out 0. Well, if they're inverses, what happens if I put 0 into f? It's going to spit out a 1. So even though I don't know what f is, because they're inverses, I know that's that little flipsy doodle there. So rock and roll. We get f prime of 0 equals 1 over g prime of 1. And that's good. That's good. So what now? Well, g prime of 1, I need to figure out. That's what I need to do next. And I look around and, hey, if I look at the very top, I actually have g of x. So I can do g prime of x. G prime of x, take the derivative. Derivative of 3 is 0. And then we get derivative of negative 2x is negative 2. And minus 3x squared. So I can find g prime of 1. Negative 2 minus 3 is negative 5. So f prime of 0 is 1 over negative 5. It's negative 1/5. Okay, so that one, you know, we had to find some knowledge based on what they gave us. Okay, now this third example this goes right back to the first example. They give you all the information. I'm going to skip that right now. If you want to do that on your own, that's fine. Let me give you a little hint. The answer is 1/4. So if you want to practice one, that's totally cool. And now let's look at this last one, because this last one is actually, it's a pretty interesting problem. You know, this is one that's like kind of an AP kind of style question that's going to be a little more difficult than kind of normal stuff. There is one typo here, and the typo is we want this to be the derivative of the inverse of f of 10 equals negative 1/8. And one of the hard parts about this problem, and I'm going to deal with it instead of rewriting stuff, is that we're going to talk about f of x and the inverse of f. And we're going to have f prime and the inverse of f prime, and we just have to watch our notation as we go through it. So I just waved my magic wand to save a second here, and we see the formulas. We have f of the inverse of f of x equals x, so that's the definition of inverse. And I went down to the red, which is our formula. Now, the inverse of f prime of 10 equals 1 over f prime of the inverse of f of 10. So there's a couple of things that we need to pull out of here. First of all, right inside of here, we have the inverse of 10, which means that somehow or another, for f of x, we are going to get an output of 10. So, you know, this is saying what is the input of f to get an output of 10? Because if we input 10 into the inverse, it should kick out. Its output should be the input of f. So that's, you know, that's what we're thinking here. But we also know that this answer is negative 1/8. So this is 1 over negative 8. Now I'm giving the negative to the bottom because there's no negative up here on top. So I just gave it to the bottom. This is telling us something that's interesting, something we need to know, is that the derivative f prime of something equals negative 8. So I need to know when is f prime of x equal to negative 8, and let's start to piece this stuff together. We need to check, are there f of x's that equal 10 that also have derivatives that equal 8? And we're just going to go through and check those. We're going to check both conditions for each of these things and see what happens. If you have a better way of doing it, please let me know, because I'd love to see it. This is, and I didn't note this at the beginning, this is a calculator problem. Okay, I don't know that you need a calculator, but it makes life easy. So let's say we go up and we say, well, hey, can this f of x equal 10? Because we want to know, can we have an output of 10? Well, sure we can. If we subtract 10 from both sides, actually, let's subtract 15 from both sides. We get negative 5x equals negative 5. And then we divide both sides by negative 5. We get x equals 1. So that could happen. We could go a 110 there. So at x equals 1, will we get a derivative equal to negative 8? Well, what's our derivative? F prime of x is negative 5. Oh, sadness. This derivative is always negative 5. It will never be negative 8. So, nope, it can't be this one. All right. Can this one ever have an output of 10? Well, yes, it can. Now, how do we do that? Okay. We can go ahead, and I think I have a typo on here. Yes, I do have a typo on here. I apologize when I got this problem. That's my second typo. That's a 14. It's okay. I didn't give you this problem to begin with anyhow. So that's a 14. So if we go ahead and solve this, make it equal to 0, we get negative 2x to the third minus 2x. We subtract 10. It's plus 4 equals 0. And we actually get x equals 1. And if you plug that in right away, you can see it. There's only one value, x equals 1. But again, admittedly, I did that on my calc. Okay, so x equals 1. So what that says is that, again, we have a coordinate point over here. We can get 110 on this problem. Now the question is, can we get the derivative? Can we get the slope to be a negative 8? Well, we have to do f prime of x. So f prime of x is negative 6x squared minus 2. And can that equal negative 8? Yeah, let's see. Can it equal negative 8? Add 8 to both sides. Negative 6x squared plus 6 equals 0. I'm going to factor out a negative 6 to give me x squared minus 1 equals 0. And lo and behold, x equals plus or minus 1. So there's our answer, x equals 1. Why is it x equals 1? Because x equals 1 does two things. First of all, x equals 1 creates a y value of 10, which this sort of told us, and we really saw it when we got down yonder here, okay? And it gives us a derivative equal to negative 8. This is your yes. This is your answer. Now, we can go through and check the rest, okay? And if you check the rest, well, what do? Again, can the y value equal 10? You can check that for each. Up here, the y value can equal 10, and guess what? This gives you x equals 1 again. And down here, this gives you x equals 0. Okay, and then you go through and you check your f of x's, or excuse me, your f prime of x's. You check, hey, can f prime of x equal negative 8? And when you take that derivative and check it, you're gonna get something that looks like this: negative 5x to the fourth plus 4 equals 0. And I assure you, 1 does not answer that. So those two things aren't going to match up. So that would be a no. And this one's just goofy enough. The answer to this, again, would be x equals 0. If we let this equal 10, the answer would be x equals 0. When we do f prime of x, we get negative 2e to the negative 2x minus 1. And we want to know, can that derivative equal negative 8? And you end up getting negative 2e to the negative 2x plus 7 equals 0. And when you graph it, and even at this, I know the answer has to be 0. If I throw 0 in there, this does not work. So that's another no. This is kind of a Big Daddy problem here, which is fine. You know, that's if you can knock this one out of the park, you're doing pretty well. Most problems are a little more like the ones above. So sorry for the long video, but this is inverse trig functions.